This video lesson is on one of the most important topics you will see this year, and that is polynomials. We will look at both adding, subtracting, dividing, multiplying polynomials, as we will in this video, as well as factoring in the next couple of videos. Some basic definitions first, right? A variable is anything that can represent a number. Often we use letters like X, Y, or Z. And right here, both of these are a form of an algebraic expression, which is really just a variable that's combined by adding, subtracting, multiplying, dividing, and so forth. Special cases of polynomials is one, a monomial, right? That's going to be a mono or a single term, but it's anything that can be written in the form ax to the k, where a is a real number and k is a non-negative integer. So something like x squared, negative 3x to the fourth. Those are both monomials, right? 2x to the negative 5, right? That is not a monomial because it's negative. How about the square root of x, right? That also doesn't follow in our non-negative integer, right? That has a rational exponent. So those are both not polynomials. If we combine two monomials, right? 2 makes bi, we'll get a binomial, right? An example of that might be 2x plus 3. Those are two monomials added together. Or we could have 7x to the 100 minus 13x squared, right? Those are both examples of binomials. And then a trinomial, you guessed it, it's got 3 terms, and that will lead us up to, if we have more than 3 terms, it's called a polynomial. Our formal definition of a polynomial, right, is any expression that's in the form a sub n, x to the n, a sub n minus 1, x to the n minus 1, and so forth. What this means is that each of these a sub n's, those are coefficients, right? Here are your degrees of each of your monomials right there. And notice they are non-negative. And you can have many terms or you can just have a single term. The degree of the polynomial, right, that's going to be your highest degree. That's going to be whatever your highest exponent is. So for example, a polynomial might be something like 2x to the fifth minus 3x to the fourth plus x cubed minus 17x squared plus 7x plus 22. These are each your coefficients, right? And it's okay to have a coefficient of 1, just like there is there. And you have exponents. Now I have every single, right, even x to the 1 and x to the 0. This is x to the 0 represented. You don't have to have all of them to be a polynomial. And this example would be a polynomial that has a degree of, right, its highest exponent. So it would be a degree 5 polynomial. How about if you had something like 3x to the 100th minus 2x to the 70th plus 17, right? This would be a degree 100 trinomial because there are 3 terms. So here's a chart with a couple different examples on it. Here are examples of all different types of polynomials, right? Their types are, we have the words trinomial, binomial because there's 2, monomial because there's 1. If you look at the third one here, right, it's got 4 terms, so we're going to call that a 4-term polynomial, right? These are all types of polynomials. The one that people often forget is just a single number like 6. Yes, that's a polynomial, right? It's a monomial, and the degree is 0 because we could write this as 6x to the 0. Because again, your degree is the highest degree, the highest exponent that you have, right? Here is a degree 8 because 8 is the highest exponent that I see. And then each of your individual values here, those are just called terms. Let's move on to some basic operations. Up first is addition and subtraction, right? We can add and subtract polynomials, but remember, they have to have like terms. Just like we did when we had radicals, you had to have the same radicand. You have to have the same degree to be able to add or subtract them. And I just wanted to point out, be careful when you have a minus sign in front of parentheses, that's going to get distributed to every single term there. There's a couple different strategies you might want to do when adding and subtracting, especially when we have a lot of terms, and that's either to maybe mark each of the same degrees in the same color or the same symbol, or do some sort of cross out so you don't lose anything. So I'm going to actually underline with different colors. So we've got a x cubed and another x cubed. That will give me 2x cubed. And then we've got, for second, we've got a negative 6x squared and a positive 5. Adding those together, we'll get a negative x squared. And then a 2x and a negative 7 will give me a negative 5x. And lastly, my constant terms, I've got a 4 here. I don't have anything there, so it's just going to be a plus 4. In the second example, we're finding the difference or subtracting. Again, what I just talked about is be careful of those subtraction signs and make sure you apply them to every member. So you might even want to write out minus x cubed, minus 5x squared, and then a minus minus will give a plus 7x. Now, let's look at our degrees. We've got an x cubed and a minus x cubed. Whoop, they will cancel, so I will have a 0x cubed, and you don't even need to write that down. Squared terms, I've got a negative 6 and a negative 5, which is a negative 11x squared. Then I have a plus 2x and a plus 7x, which will give me a plus 9x. And finally, that little 4 by himself. So it's negative 11x squared plus 9x plus 4. Multiplying is up next. The most common way will be multiplying a binomial by a binomial, like right here. And we can use a method that's called FOIL, and some of you may have heard that. It stands for first outers, inners, last, or first outside parts, inside parts, and last. But you don't have to just multiply binomials. We'll do some other methods as well, but something similar to FOIL will work for them. So using the FOIL method, multiplying these two binomials right here, we're going to multiply the first terms in each, which will be the x and the minus 4x. That will give us minus 4x squared. Then we will multiply the outers. Those will be the terms on the outside, the x and the 5, so that'll give us a plus 5x. The inners, right, those will be the terms on the inside, right? That will be the 3 is on the inside and the negative 4x. So together those will be a negative 12x. And then finally the last, right, those will be your last terms in each. And that is the 3 and the 5, which will give you a plus 15. Combining, we'll get a negative 4x squared. The 5 and the negative 12 combine to be a negative 7x plus 15. So number 4, the next problem, we can't use the FOIL method because we have a binomial, but it's multiplied by a trinomial. But the same method kind of works where we multiply each term by each other. So what do I mean by that? The way I like to work this is I'm going to start with the 2x, and I'm going to first multiply it by the x squared, then by the negative 5x, then by the 4, and then I'll do the same thing with the 3. So that will give me 2x times x squared is 2x cubed. 2x times negative 5x is minus 10x squared. And then finally the 2x times the 4 will give me a plus 8x. And then next I'm going to take my 3 and do the same thing, multiply it by each of these terms. So my plus 3 times x squared will give me a 3x squared. 3 and the minus 5 will give me a negative 15x. And then finally the 3 and the 4 will give me a plus 12. Now, just like we did with our adding and subtracting, we need to combine like terms. So my 2x cubed is all by itself. I've got a negative 10x squared and a 3x squared, which will give me a negative 7x squared. Then I've got an 8x and a negative 15x, right? That's a negative 7x. And finally, my plus 12 is all by itself. And that's our final answer. So now let's look at a couple of special patterns. The first is the difference of two squares, right? And this will actually help us when we get to factoring as well. But notice what it's saying is if you have a plus b and a minus b, right? It's the difference between the two of them, when you multiply them together, it will just be a squared minus b squared, because what happens is your inners and your outers cancel. So in our example, we have find the product of x plus 6 and x minus 6. Well, what is our a in this example? Well, our a is the x, so that's going to give us a squared or x squared, and then minus. And what's our b in this example? Well, it is 6. So 6 times 6 is 36, and x squared minus 36 is our answer. Now, you could also FOIL this out, and you would get this exact same answer. So if you're always stuck, remember, you can always FOIL, but these little nice short patterns kind of help quicken our work. We can do the same thing in question 6. Notice again, I've got square root of x plus 2 and the square root of x minus 2, right? The signs are the opposite, but everything else is the same. So in this case, our a is equal to square root of x, and our b is equal to 2. So a squared will be square root of x squared, which is just x, minus b squared is 2 squared, and that is 4. Again, you don't have to memorize this difference of 2 squares. You could always just do straight out foiling for multiplying, and you will get these same answers, just like I did right here. So see how these are the exact same answer as if I were to FOIL it. Our next pattern is the perfect square of the sum or difference. So notice this is a little bit different. We have two binomials that are the same, right? I've got 5x plus 1 squared, or 3x minus 2 squared. So when you have the square of the sum of two binomials, you're going to have a squared plus 2ab plus b squared. And when you have the square of the difference of two binomials, you'll have a squared and b squared is the same, but the middle part will be minus 2a. Do you have to memorize and use these rules? No, you do not. You can always just FOIL. This is just a little trick that you can use to help remember multiplying. That makes it a little bit faster, and it's also going to help when we start to factor things as well. So when we're using these, right, in our 5x plus 1 all squared, our a is equal to 5x, and our b is equal to 1. So if we follow this pattern, we're going to get 5x all squared plus 2 times a times b plus b all squared. And if we simplify this out, don't forget, apply the square to both. We'll get 25x squared plus 10x plus 1. Now let's try a perfect square with a difference, right? 3x minus 2 all squared. We're going to use this formula. And now let's identify what our a and our b are going to be. Our a will be 3x, and it's a minus b, so our b will equal a 2. And again, now we're going to take our a all squared, now minus 2 times a times b, and then plus our 2 squared. And if we simplify this, we'll get 9x squared minus 12x plus 4. Again, these are just special formulas or rules that you can use to help with multiplying out polynomials. And finally, let's do a little bit of factoring to start, and we're going to do that with using the greatest common factor, or GCF. A GCF is the greatest common factor that both terms would have, and this could be a number or it can be variables with powers as well. So to start with a simple case, do you remember if you have 16 and you have 24, what the GCF is? What's the largest number that goes into both of those? And that is 8. And you could get these by doing a factor tree to get the prime factors, right? 24 is going to be a 2 times 2 times 2 times 2. 16 is going to be a 2 times 2 times 2. What do they have in common? They both have in common 3 2's, which, bam, bam, that becomes the 8. And we're going to do the same thing now when we have variables with exponents. In our first example here, let's just list out the prime factors, just like we did with the 16 and the 24. 10x squared is 5 times 2 times x times x times y times y times y. And 15 is equal to 5 times 3 1x, and then we've got 2y's. Now, just circle what they have in common, right? We've got a 5 in common, we've got 1x in common, and we've got 2y's. If we put that all together, 5x y squared, that's our greatest common factor, or GCF. And we can use this when we're starting to factor. So jump down to number 3 here, which is saying factor now those two terms that we had right here. Well, we know that their greatest common factor is 5xy squared. And then what are we left with? Well, we're left with, from the left term, 5 and 15. We're left with 3. X and x squared, we're left with x. And y squared and y cubed, we're left with 1y. Plus, now factor out the second term. 5 out of 10, we get 2. All of our x's go, and all of our y's go. So here in factored term, and all I can do is put my parentheses right here, is our answer. 5xy squared times the quantity 3xy plus 2. Nice and factored. Now try the whisk, and I will see you in class real soon.